Hi, I'm Zoe from STEM for Others. In this lesson, we're going to explore two key concepts for all these xt, vt, and at graphs. Number one, the slope, and number two, the area under curve. Going back to our example where the car is traveling forward at a constant rate, let's explore how we can understand the car's velocity using the xt graph. As we plot the chart when the car moves 1 mile to the right every minute, it gives us a straight line that slopes upward. To recall the definition of velocity, it is the rate of change of position, or in other words, delta x over delta t. Now, what is delta x in the chart? Delta x is the change in position of the car, meaning the displacement between the initial and final position. In the chart, this is the vertical distance between the blue and magenta dots, or sometimes we call it rise. How about delta t? Delta t represents the change in time during which the car moves from one position to another. On the chart, this is the horizontal distance between the blue and the magenta dots and is sometimes referred to as the run. And we know that the rise over run gives us a slope. Therefore, the velocity in the xt graph can be represented by the slope of the line. In this case, velocity v equals to delta x, which is 20 miles, over delta t, which is 20 minutes. So v equals to 1 mile per minute. The slope of the linear line in xt graph is constant, meaning the velocity is constant at 1 mile per minute. This constant slope reflects a steady velocity. So, it's not difficult to understand that the corresponding velocity time, or vt graph, will be a constant horizontal line at 1 mile per minute on the y-axis. This horizontal line shows that the velocity remains the same throughout the time period.